If you don't eat meat or fish, creatine matters to you more than it does to almost anyone else in this conversation. Not because vegetarians are deficient in some clinical sense, you're not, but because the gap between your current muscle creatine levels and the performance ceiling that supplementation can reach is, on average, the widest of any dietary group studied. Understanding why that gap exists and what closing it produces is the most concrete, well-evidenced case for supplementation that exists anywhere in nutrition science. Here's the biology. Creatine in food is found almost exclusively in animal muscle tissue. Red meat contains roughly 4 to 5 grams of creatine per kilogram of raw weight. Fish and seafood contain comparable or slightly lower amounts depending on species. Poultry contains less than red meat, but still a meaningful quantity. Plant foods, vegetables, legumes, grains, nuts, fruits, contain essentially no creatine. None. An omnivore who regularly eats red meat might absorb 1 to 2 grams of dietary creatine per day. Add that to the approximately 1 gram of daily endogenous synthesis from the liver, and a meat-eating individual is taking in 2 to 3 grams of creatine per day from all sources. A vegetarian or vegan is taking in only the 1 gram from internal synthesis. That's it. Over time, this difference accumulates into a measurable gap in muscle creatine stores. Multiple studies using muscle biopsy techniques have confirmed that vegetarians and vegans carry significantly lower total creatine in their muscle tissue than omnivores, even after controlling for training status and muscle mass. Muscle biopsy is the only reliable way to directly measure muscle creatine content, which is why these studies carry particular weight. The typical finding is around 20 to 30% lower resting muscle creatine in plant-based individuals compared to meat eaters. Now, here's where that gap translates to something meaningful. Muscle creatine content determines the size of your phosphocreatine reservoir, the fast-charging energy buffer that sustains power output during intense exercise. If your reservoir starts lower, it runs out sooner. You hit the wall earlier in a set. Your sprint speed degrades faster across repeated bouts. Your interset recovery is slower. These aren't just numbers on a biopsy slide. They're performance differences that accumulate across every training session. When vegetarians and vegans supplement creatine at 3 to 5 grams per day and reach full saturation, the absolute increase in their muscle creatine stores is larger than it is for omnivores, because they had more room to fill. Studies consistently show that plant-based individuals achieve creatine loading gains that are 20 to 40% larger in absolute terms than those seen in omnivore counterparts. And that larger absolute gain translates into proportionally larger performance improvements. The cognitive story is equally compelling. Your brain uses creatine as an ATP buffer through the same phosphocreatine system as your muscles. Vegetarians and vegans show lower baseline brain creatine levels in neuroimaging studies compared to omnivores. This matters because brain creatine directly influences working memory, processing speed, and resistance to mental fatigue, particularly under conditions of sleep deprivation and cognitive stress. In randomized trials specifically comparing vegetarians to omnivores on cognitive outcomes after creatine supplementation, vegetarians show dramatically larger improvements across every cognitive measure tested. Processing speed improvements that are barely detectable in omnivores become substantial and statistically robust in plant-based individuals. The cognitive benefit alone, independent of any physical performance consideration, makes creatine one of the highest value supplementation decisions available to anyone on a plant-based diet. Will creatine fully close the gap between a plant-based diet and an omnivore diet for all aspects of performance? Not for everything. It addresses the creatine-specific deficit, not the anabolic amino acid profile from complete animal protein, the heme iron from red meat, or the long-chain omega-3s from fish. Those are separate nutritional considerations with separate solutions, but the creatine deficit is one of the most straightforward nutritional gaps in plant-based diets to close, and supplementation closes it completely. 3 to 5 grams of creatine monohydrate per day, consistently taken, brings plant-based muscle creatine stores up to omnivore range, and in some cases beyond. If you're plant-based and not supplementing creatine, you're training with a measurably smaller energy reserve than you could have. That's a fixable problem, and the fix costs almost nothing per day.